Okay, now that we know what a chemical reaction is and how to balance them, now we're going to start to see if we can talk about the different types of reactions. There's actually going to be 5 that we're going to learn here. And some of you may have gotten this, especially if you took physical science with Mrs. Brew. She discussed the types of chemical reactions a little bit. We're just going to talk about 2 today, synthesis and decomposition. And these are 2 of the easiest reactions that we can identify, okay? So a synthesis reaction, if you can kind of think of where you've heard the word synthesis before, probably the word that comes to mind is photosynthesis, okay? And that is kind of what synthesis is. Synthesis is when we take 2 reactants and create 1 product, okay? So synthesis reactions are really easy to identify because you only have 1 thing on the product side of the arrow, okay? So a synthesis reaction is when 2 reactants become 1 product, right? It's like 2 people getting together to dance. Often, when the reactants are elements, 1 or both will become covalent compounds. Okay, so let's look at some examples, and then we'll balance while we're doing that. So creating water is actually an example of a synthesis reaction. We take hydrogen gas and oxygen gas, and we create water vapor. Okay, so let's go ahead and balance this one really fast. So 2 hydrogens, 2 hydrogens, 2 oxygens, 2 oxygens. So I need to put a 2 here, which then makes hydrogen 4. So I need to put a 2 here. Okay. And then I have 2. I can also have an example of a synthesis reaction that starts with 2 covalent compounds, and that's kind of what I have here. And I'm creating an acid. So whenever I have 2 covalent compounds, they come together and form an acid. And this acid is specifically carbonic acid. So let's go ahead and balance this guy. So oxygen shows up in all 3 places, so I'll balance oxygen last, but let's look at carbon. So I have 1 carbon, 1 carbon, 2 hydrogens, 2 hydrogens, so everybody's balanced. And then I have 2 oxygens here, 1 oxygen here, so it's 3. And then I have 3 oxygens on the other side, so therefore it's already balanced. I don't need any coefficients. And then number 3 is a metal and an oxygen plus water, and I make a metal hydroxide. Okay, so let's go ahead and balance this guy. So 1 product, 1 product, 1 product means synthesis reaction. So 1 magnesium, 1 magnesium, 2 oxygens, 2 oxygens, 2 hydrogens, 2 hydrogens. Therefore, this is also balanced. Okay, so that's the first reaction, type of reaction that I would expect you to be able to identify. The next one that I'm going to talk about really quickly is decomposition. So decomposition is actually going to be the opposite of a synthesis reaction, meaning we're going to have 1 product and break that product into either 2 or more reactants, specifically 2 reactants, okay? So a decomposition is where you have 1 reactant and it breaks up and becomes 2 products. So this would be like our couple from the front. They were happy when they were a synthesis reaction. Guy A probably said something bad about girl B's cooking, and that's what made her go away. So decompose means to actually break up or break apart. So decomposition, we have 3 different types of decompositions that we can come across. We can come across a binary compound decomposing, which means that there's only 2 things inside of the reactant. So, for instance, this would be 1 element, 2nd element, and then they just break up into each other. So, for example, mercury oxide will be mercury 2 oxide. Mercury 2 oxide breaks down into mercury and oxygen gas. Remember, we can't just write O because O is not found in nature, O2 is. So then we would have to balance this by putting a 2 here and a 2 here. Okay? I'm just going to talk about these examples. I do want you to make sure that you balance these, though. We can also decompose water just like we synthesized it by breaking them apart and making H2 and O2. And then here's another one, hydrogen iodide can break apart into H2 and I2. So that's the first decomposition reaction. The second one is a chlorate decomposition reaction. So if you remember, ClO3 minus 1 is chlorate. So anytime we have a metal attached to chlorate and it breaks apart, we're going to make a metal chloride and oxygen gas, okay? So for example, potassium chlorate, which was the gummy bear experiment that I did during demos, potassium chlorate is going to decompose into a metal chloride, which is potassium chloride, and oxygen gas. So let's go ahead and balance this. Potassium and chlorine are currently balanced. Oxygen is not. I need to make them both 6, so I'm going to put a 3 there and a 2 there, which then makes my potassium chlorine 2, so then I need to change that. You also see calcium chlorate and aluminum chlorate breaking down into their counterparts. And then the last decomposition reaction that we can have is a carbonate decomposition. And that's going to be, if you remember, carbonate is CO3 negative 2. So anytime we have a metal and carbonate, it's going to break up into, I'm sorry, I lost you. Sorry about that. So when I have a metal carbonate, it's going to break up into a metal oxide, and carbon dioxide is the second product. Okay, so for example, nickel carbonate is going to break up into nickel oxide and carbon dioxide gas. So to balance this, nickel is balanced, carbon is balanced. I have 3 oxygens, so this is also balanced. So go ahead and make sure that you're balancing B and C from each section here, and that's what I'm going to check to make sure that you watch this video. Thanks for watching.